If you don't have a technical background, but you still want to learn the basics of artificial intelligence, stick around because we're distilling Google's 4-hour AI course for beginners into just 10 minutes. I was initially very skeptical because I thought the course would be too conceptual. We're all about practical tips on this channel. And knowing Google, the course might just disappear after 1 hour. But I found the underlying concepts actually made me better at using tools like ChatGPT and Google Bard, and cleared up a bunch of misconceptions I didn't know I had about AI, machine learning, and large language models. So, starting with the broadest possible question, what is artificial intelligence? It turns out, and I'm so embarrassed to admit I didn't know this, AI is an entire field of study, like physics. And machine learning is a subfield of AI, much like how thermodynamics is a subfield of physics. Going down another level, deep learning is a subset of machine learning, and deep learning models can be further broken down into something called discriminative models and generative models. Large language models, LLMs, also fall under deep learning, and right at the intersection between generative and LLMs is the technology that powers the applications we're all familiar with: ChatGPT and Google Bard. Let me know in the comments if this was news to you as well. Now that we have an understanding of the overall landscape and you see how the different disciplines sit in relation to each other, let's go over the key takeaways you should know for each level. In a nutshell, machine learning is a program that uses input data to train a model. That trained model can then make predictions based on data it has never seen before. For example, if you train a model based on Nike sales data, you can then use that model to predict how well a new shoe from Adidas would sell based on Adidas sales data. Two of the most common types of machine learning models are supervised and unsupervised learning models. The key difference between the two is supervised models use labeled data and unsupervised models use unlabeled data. In this supervised example, we have historical data points that plot the total bill amount at a restaurant against the tip amount. And here the data is labeled. Blue dot equals the order was picked up, and yellow dot equals the order was delivered. Using a supervised learning model, we can now predict how much tip we can expect for the next order given the bill amount and whether it's picked up or delivered. For unsupervised learning models, we look at the raw data and see if it naturally falls into groups. In this example, we plotted the employee tenure at a company against their income. We see this group of employees have a relatively high income to years worked ratio versus this group. We can also see all these are unlabeled data. If they were labeled, we would see male, female, years worked, company function, etc. We can now ask this unsupervised learning model to solve a problem like, if a new employee joins, are they on the fast track or not? If they appear on the left, then yes. If they appear on the right, then no. Pro tip, another big difference between the two models is that after a supervised learning model makes a prediction, it will compare that prediction to the training data used to train that model. And if there's a difference, it tries to close that gap. Unsupervised learning models do not do this. By the way, this video is not sponsored, but it is supported by those of you who subscribe to my paid productivity newsletter on Google Tips. Link in the description if you want to learn more. Now we have a basic grasp of machine learning. It's a good time to talk about deep learning, which is just a type of machine learning that uses something called artificial neural networks. Don't worry, all you have to know for now is that artificial neural networks are inspired by the human brain and looks something like this. Layers of nodes and neurons. And the more layers there are, the more powerful the model. And because we have these neural networks, we can now do something called semi-supervised learning, whereby a deep learning model is trained on a small amount of labeled data and a large amount of unlabeled data. For example, a bank might use deep learning models to detect fraud. The bank spends a bit of time to tag or label 5% of transactions